Let's look at how to solve some problems involving all positive values. So let's start off here with some adding and subtracting, and integers are pretty straightforward, so let's do a little more complicated here. Let's do some rationals, adding and subtracting. So for this one, we've got 10 and we've got 4.9, and they're being subtracted. So 10 is not a decimal, but we can very easily make it a decimal, and 4.9, of course, is a decimal. So 4.9 has one decimal place shown, so we've got to rewrite 10 so that it also has one decimal place shown. So we're going to put the decimal right at the end here. If there is no decimal, it goes on the right. And then we're going to show one decimal place with a 0 placeholder that says, 10.0 is the same as 10. So we're going to take 10.0 and we're going to subtract 4.9 from it. This is very similar to subtracting 100 minus 49. So what we're going to do is essentially ignore the decimals now that they're lined up. So once these are lined up vertically here, then we can just subtract like you normally would, essentially just ignoring the decimals for now. We can't do 0 minus 9, so we can't borrow from the 0, we have to borrow all the way from this 0, makes that a 10, and then we're going to make that 10 a 9 and make this a 10. So 10 minus 9 is 1, 9 minus 4 is 5, and we're going to just slide that decimal down, so our answer is 5.1. 100 minus 49 would be 51, so 10 minus 4.9 makes sense to be 5.1, or we can call that 5 1/10, because 1 is in the 10th place. So next we're going to do another problem here. Let's try one with some mixed numbers. Here we go. So this one, 6.8 minus 2 1/5. So when you've got a mixed number and you've got some decimals, it's good to put them both into the same form. It doesn't really matter. I prefer putting them both into decimals. I think we're a little bit better at subtracting decimals than we are mixed numbers, at least me personally, I am. So I'm going to rewrite 2 1/5 so it's in a decimal form. So 2 1/5 equals, well, let's think about this. So 1/5, it'd be a lot easier if that was in tenths. So 1/5, let's think about how many tenths would that be? Well, 5 to 10 would be times 2, so this is 2 tenths. So 2 tenths is equal to 1/5. So I can rewrite this as 2 2 tenths. And then tenths, now that we're in the tens, we can just write that as a decimal. 2 2 tenths, you can write like this. So now we can just easily just stack these up. 6.8 minus 2 2 tenths. And then again, just subtract like you normally would. Because your decimals are lined up correctly, we can just subtract down. So this would be a 6, this would be a 4. So our answer is 4.6, which makes sense. A little bit bigger than 6 minus a little bit bigger than 2 should be a little bit bigger than 4. So 4.6, or we can call that 4 6/10 or 4 3/5. Let's do just one more here. This is an adding problem. So now this time we've actually got two mixed numbers, and they have the same denominator. So for this one, what I would do is I would actually just add them in the form that they're already in. 11 4/5 plus 7 1/5. Well, let's think about what this means. 11 4/5 is the same as 11 plus 4/5. That's what 11 4/5 means. Same thing for 7 1/5. That means 7 1/5. So really we're just adding all these pieces together. And if we think about this, we can think about the commutative property of addition and say, well, I can add any order that I want. I can add the whole numbers first, 11 plus 7, that would be, of course, 18. And I can add the fractional pieces, 4/5 plus 1/5. And then I'll just add those two answers together. And 4/5 plus 1/5 would be 5/5, which we know better is 1. So it's 18 plus 1, which is 19. So a nice whole number answer there. I do want to look at actually one more problem involving two mixed numbers. Let's see if I can get one here. This is a pretty good one. It's not too complicated, but it does have different denominators, and that's what I was looking for. So we want to make them the same denominator. Let's think about this. If I were to make 5 4/5 have the same denominator, that would be the same thing as 5 8 tenths, because 4/5 equals 8 over 10, just multiplying both the top and the bottom by 2. The tricky part is if I try to subtract these, just kind of like you normally would, like we added the other parts, it's going to be hard because 3 tenths take away 8 tenths is not going to be easy to work with. So why don't we actually use our tenths here to rewrite these as decimals. So I'm going to rewrite this as 8 and 3/10 like this, minus 5 and 8/10 like that. And then I'm going to rewrite that, like we normally do, kind of stacked up here, as I call it, where our decimals are lined up. And then we're just going to borrow. We're going to make that 13 minus 8, which is 5. 7 minus 5 is 2. And that decimal was lined up, and it just drops down. So we can call that 2.5 or 2.5. And that's how we do some adding and subtracting with positive rational numbers.